Giant supervolcano in California is sleepy, but scientists say it's restless. A new study from researchers at California Institute of Technology, CIT, suggests that the Long Valley Caldera in eastern California is one of the two supervolcanoes in the United States. The other one is Yellowstone. Long Valley Caldera is restlessly tossing and turning as its deep magma chamber cools down for a big, long sleep. The last time the volcano blew up was roughly 100,000 years ago. Long before that, it spewed up enough ash to bury the modern city of Los Angeles beneath a kilometer of sediment. Today, the Long Valley volcano exists in a relatively sluggish state, but all is not quiet on California's eastern front. In the late 1970s, a swarm of earthquakes began to emanate from the caldera, a depression that sits atop the buried volcano. For decades, therefore, the volcano produced regular periods of pronounced unrest, which inflated and deflated the ground. Thankfully, that is not necessarily a sign of impending doom. Researchers at CIT have now found evidence that all this fussy activity is due to the supervolcano cooling down and not heating up. We don't think the region is gearing up for another supervolcanic eruption, but the cooling process may release enough gas and liquid to cause earthquakes and small eruptions, said geophysicist Zhongwen Zhan. For example, in May 1980, there were 4 magnitude 6 earthquakes in the region alone. The team's findings are based on data collected from a 100-kilometer stretch of fiber optic cable using distributed acoustic sensing. Over the course of a year and a half, researchers at Caltech used this interconnected system, which is equivalent to 10,000 individual seismometers, to catalog more than 2,000 seismic events, many of which would not have been felt by humans on the ground. This data was then plugged into a machine learning algorithm, which turned the measurements into a high-resolution map of the caldera and the volcano that lies beneath. Ettore Biondi, a seismologist from Caltech and first author of the study, says this is the first time that a network of deeply distributed acoustic sensors has revealed Earth's interior dynamics. The images produced are of exceptional lateral resolution in depths up to 8 kilometers, the team says. Even images of deeper portions up to 30 kilometers down were achieved with a remarkable level of detail. The findings show a definite separation between the large magma chamber of the volcano, sitting 12 kilometers below the surface, and the shallow hydrothermal system that sits above it. It seems that as the deeper chamber cools off, gases and liquids bubble up towards the surface, possibly causing the quakes and inflated ground. This boiling effect could induce the observed surface deformation and seismicity, researchers write. This is different and far less hazardous than what happens during an active volcanic eruption, when magma in the chamber of the volcano forces itself up into the upper crust and out into the world. The way seismic activity travels through these layers suggests the top of the magma chamber has a hardened lid of crystallized rock, which has cooled over time. As the supervolcano's activity winds down, researchers say it is beating heart. It's a beating heart. It's gradually slowing. The team plans to measure those last beats at 20 kilometers deep with a 200-kilometer long cable of seismic sensors. The study was published in Science Advances, and this is on Science Alert by Carly Casella. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.